In this example, we are going to create a sine and a cosine equation for this graph. So we're going to be able to create a whole lot of these, actually, kind of an infinite amount of these. But first off, I'm going to kind of put some pieces together, and you're going to see some similarities between the two different things. First off, that this curve has a midline. And so we are looking for kind of at the end of this, we're looking for A, either a sine or a cosine, B, and then we have a period adjustment, we have a potential phase shift, and a midline. Right, so those are all the pieces, and whether that's a sine or a cosine, that's just kind of dependent on the situation. So all of them are going to have the same amplitude and the same midline. It's this horizontal piece, like these vertical pieces are the vertical pieces. But the horizontal, I guess this will be the same because that's affecting our period. The only thing that's going to be different on every one of these is what kind of a phase shift we got going on. So let's start putting together the pieces. So we have a midline. So we have an amplitude, we have a period, we have a phase shift potential, and we have a midline. So I see midline right away that the whole curve is all kind of all focused around this line right here. So that means that our whole graph got shifted up 3. So our midline is up 3. So that would mean that we are at a +3 sitting right here. Next thing is from that midline, our amplitude from here to here is 1, 2. So don't be tricked by the fact that we have um, kind of the half marks in here. So our amplitude is 2. All right. So we are currently sitting with a 2 sine cosine kind of an equation, and then a +3 floating out of the back. The period. Period is, I'm just going to go from a low point to a low point. So from here to here, that distance is pi for our period, which is great, except what we need to do is to figure out that our formula is 2 pi over b equals our period. And so our b value, our b value would need to be a 2. 2 divided by 2 is going to get you the 1. All right, so whether we have a sine or a cosine, we have the same amplitude. The period adjustment is the period adjustment. So that's going to be a 2 times, 2 times. And then we're going to have some sort of a midline, which shifted us up 3. All of that is exactly the same 100% of the time. The difference is whether we're talking about a cosine graph, which starts in a different location than a sine graph. So if you're looking at a sine curve, so sine starts on the line, and our graph does not. A sine curve starts here, not here, right? So if we're doing sine, then we have this phase shift to account for. So this graph would have been shifted right. Let's see, this is a pi over 2. So let me drop that all the way down. It would be shifted here. So that's a pi over 4. So if we were doing a sine curve, then we would have had a sine would it need to be shifted to the right pi over 4. So in our equation, we would have x minus pi over 4 to account for a left and right shift in the opposite direction of that value. So that would be if we were starting the sine. So we have an amplitude if we would start it here, then we have an amplitude of 2, the whole graph got shifted up 3, and the period would end here, which is still exactly a period of 4 pi. All right, so that's sine. There's another version of that too. We could have shifted it all the way to here, then we'd have a shift of, I don't know, 1, 2, 3, 4, 5 pi over 4. So a minus 5 pi over 4 would have done the exact same thing. Or we could have shifted it back, but now we have a negative, like we have a reflected sine curve. So if we put a plus pi over 4, then we would need to put a negative in here to reflect it. But this thing could go on and on and on. We could have shifted it back to here. So then we would have had a 1, 2, 3. So a 3 pi over 4. So this thing could start anywhere along here. You just have to account for it of whether you reflected it and how many pi over 4s did you shift it. So that would be one version of the many different versions of sine. So ours was just we're shifting it to the right. Otherwise, the amplitude, there was no reflection. The period is the period, and the midline is the midline. Now, cosine starts at a high point. Ours starts at a low point. So we can fix that by reflecting it. And if we reflect it, now we're starting here, we don't have any kind of a phase shift. So then we don't need this. We can squeeze this in. That is just 2 times x plus 3. So that's one version, right? Or we're like, all right, I would rather shift and not reflect it. So if I didn't reflect it, then I would have a 2 cosine. My period is the period, so I need a 2 there. But we would shift it right pi over 2. So that would be an x minus pi over 2 plus 3. That's another version. Or you could have shifted it left pi over 2. So then a plus pi over 2 would also work. So either you're reflecting it or you're not reflecting it, right? And let me go back to this one. If we wanted to reflect it because we wanted to shift it back here for whatever reason, then a negative 2 sine 2, we would be shifting it left. So that would be an x plus, and then we would still be at that pi over 4 mark. So technically there's an infinite amount of these because you could have started your whole graph over here, here, this high point, but it potentially never ends. So lots of different answers, lots of different possibilities, but every single one of these can be written as a sine or a cosine, but you'll have to do some sort of a phase shift, whether it's a sine or whether it's a cosine, and just depending upon the graph.